In this video, I explain gradient descent by showing you a small example of a neural network. If you are watching this video, you have probably searched for gradient descent and found magic formulas like you see on the screen. I am not a mathematician, but I still need to use gradient descent in a Python neural network. Here is what I've learned. Here is a neural network with one neuron, one input and one output. The line from input to the neuron has a weight. The neuron multiplies the input by the weight and results in an output. The network is trained with this training data. For each element, the network predicts the output. The network calculates the error for each element and calculates an average error over all the elements. The function that returns the error is called the cost function. The average error is now used to adjust the weight. The calculation to update the weight is not a trivial exercise, because you have to differentiate the cost function and understand a bit of calculus. But for this video, it is enough to understand that the weight will be adjusted and the adjustment is just a number. Now imagine a neuron with 3 inputs. The whole learning process will be the same. This time, the training data has 3 inputs and 1 output. Again, an average error is calculated. Now, 3 weights have to be updated. Again, I'm going to spare you from diving into calculus. All you need to know is that the error will be used to create 3 weight changes. These changes are going to be stored in a column vector. The vector is called the gradient. And now we are close to answering the initial question: what is gradient descent? The gradient is used to update the 3 weights. The network is now a little bit better in predicting and will go over the training elements again. A new gradient is calculated. The gradient is used to update the weights again. The network is now even better in predicting and will go over the training elements again. The more the network is trained, the smaller the weight updates will be. A better trained network results in a smaller error. Gradient descent is the process of nudging the weights into a direction that minimizes the error. For non-native English speakers like myself, it is even interesting to mention that descending means going down. That makes it easier to understand the relationship between the words minimizing and descending. In this case, they both mean bring them down. Let me repeat what gradient descent is. Step 1. Calculate the gradient. Step 2. Adjust the weights. Step 3. Repeat until the error minimizes. I hope this helps. See you in the future.